You're watching molten cobalt and tungsten carbide powder being fired onto a compressor rod at twice the speed of sound. Because of this process, compressor rods, centrifugal gas compressors, turbine parts, and other components can be repaired quickly and be made to last longer. New parts can also be coated to increase their service life and reduce downtime and maintenance costs. Here at Fusion Incorporated, rotating components are repaired and ground to the exact tolerances required in today's critical equipment. Fusion Incorporated is an internationally known company that repairs industrial crankshafts up to 25 feet long. They're also a machine and grinding plant that builds and repairs all types of rotating and reciprocating components. Their services include metallizing, all types of plasma and ceramic coatings, and manufacturing of OEM replacement parts. But perhaps the star of the show at Fusion Incorporated is the high-velocity tungsten carbide coating process. Fusion's tungsten carbide coating process has been in wide industrial use since the late 1970s. Basically, it's a way to apply an extremely hard surface that can be ground to close tolerances and will far outlast conventional metal surfaces. When a part first arrives, it's given a close visual and diametric inspection. From this moment on, critical information about the part will be permanently recorded on a computer hard card.
If need be, the part is given a magnetic particle inspection. If it is, it'll be demagnetized afterwards to a residual level of 2 Gauss. Stainless parts can be dye-penetrant inspected. Then comes the grinding to undersize. Here, a centrifugal compressor shaft is being ground to 10/1000ths of an inch undersize. Every part, new or used, spends 4 hours in a heat soak to cook out diffused gases that might interfere with the coating and to prevent hydrogen embrittlement. This compressor rod will eventually be allowed to cool down slowly at room temperature.
A compressor shaft is now prepared for grit blasting by carefully masking the areas adjacent to the surfaces to be coated. To give the tungsten carbide a good surface to bond with, the part is grit blasted with aluminum oxide. Different grit sizes and air pressures are used to create the various surface finishes required. For thicknesses up to 5/1000ths of an inch, the surface is finished to 100 to 150 RMS. If the coating will be more than 5/1000ths thick, the surface finish will be 200 to 350 RMS. A clean metal finish is absolutely essential for maximum coating bond strength. Time is important. Since rust can attack unprotected steel very quickly, the part is coated within 1 hour of grit blasting. This one is now ready. The high-velocity coating process has its own special chemistry, with about 20 different blends of material available. This compressor rod, for example, is to be coated with a mixture of 88% carbide and 12% cobalt. If the part were destined for an especially corrosive environment, a nickel matrix would be used instead of cobalt. There is no single ideal coating. The decision depends on the part and the service environment. Temperatures, pressures, RPMs, and chemical exposure are taken into consideration. It's very important that the substrate be held at the proper temperatures at all times during the coating process. This high-velocity oxy-fuel method lays down a coating with terrific bond strength and low porosity. That means it works well on high-speed rotating equipment as well as in high-pressure service. To allow for finish grinding, the coating is built up 10/1000ths over the finish dimension. Diamond wheels are used to grind the carbide coating back down to spec, guided by extremely precise equipment. During the process, the operator with many years of experience will closely monitor size, concentricity, and taper. After grinding, every part is given a dye penetrant check to be sure there are no blisters, cracks, or pits. The part will be honed and super finished to the specified RMS finish. Generally, a 12 to 16 RMS is called for on rotating equipment. On this compressor rod, though, the surface will be finished to 8 to 10 RMS. And if it's required, a 2 RMS finish is attainable. The surface finish, dimensions, and runouts are recorded on a final inspection sheet. This information is kept in the job file for future reference. A major virtue of the tungsten carbide coating process is that job turnaround is faster than with other methods, so there's much less downtime.
Fusion Incorporated uses highly advanced spray and grit blasting equipment that captures all possible contaminants, preventing them from escaping to the atmosphere. Spent materials are recycled whenever possible, and waste is disposed of with great care. Fusion is a company built on know-how and good service. By the time a job is completed, sprayed with Cosmoline, and prepared for shipment, it's been through some of the most advanced and careful handling in the industrial world. And all to one simple purpose: to extend the service life of your equipment. For more information on Fusion's carbide coating process or any of the other services that can make your rotating or reciprocating equipment last longer and work better, call us anytime.